This is Suseendran and Anirban Ray. Now we are going to present our final year project demo. So our project title is Qos-guaranteed distributed routing protocol using neighbor selection algorithm with any cast transmission and short transmission hops for hybrid wireless network. So we are guided under Dr. S. Qos-guaranteed and our project coordinator Srinivasan sir. So the abstract of our project. So wireless communication is one of the most vivacious areas in the communication field today, as we know. This technology is biggest contribution of mankind. Wireless communication involves the transmission of information over the distance without help of wires, cables, or any other forms of electric conductors. The wireless communication supports dedicated quality of service, which is which we are going to concentrate on our project. Required for wireless applications. A hybrid wireless network is an extension to an infrastructure network, as we know, where a mobile host may connect to an access point using multi-hop wireless routes via the mobile host also. So, the main target of our project is to implement this in MANET. So for implementing this, we have 5 types of algorithms which we have segregated as a 5 modules in our later batch project. So this includes neighbor selection algorithm, packet scheduling algorithm, segment resizing algorithm, and traffic redundant and elimination algorithm, and redundancy elimination based transmission algorithm. And the main objective of our project is like taking advantage of fewer transmission hops and any cast transmission features of hybrid wireless networks. QoD, which is quality oriented distributed routing protocol, which we call as QoD, transforms the packet routing problem to a resource scheduling problem. So the analytical and simulation results based on the random waypoint model and the real human mobility model show that QoD means quality of service oriented distributed routing protocol can provide high QoS performance in terms of overhead, transmission delay, mobility resilience, and scalability. So our existing system. So we have taken our existing system as reservation based QoS routing protocol, where it has been proposed for MANETs that they create routes formed by nodes and links that reserve their resources to fulfill QoS requirements. Although these protocols can increase the QoS of MANETs to a certain extent, the main disadvantages of our existing system, which is reservation-based QoS routing protocols, that they can't provide QoS guaranteed services first of all. Then they suffer from invalid reservation and race condition problems also. So here, what is invalid reservation means? That the reserved resources become useless, and the race condition problem means double allocation of same resources to 2 different QoS paths. And coming to our post system, so going through all those existing system with those reservation race condition problems and all those stuff, so we got a new idea that to implement means our project in using these 5 different algorithms, like as I told you in abstract, neighbor selection and traffic redundancy, packet scheduling, and all those. So finally what we are going to achieve in our proposed system is like the terms of overhead, transmission delay, and mobility resilience and scalability. So finally the outcome will be of QoD, which is quality oriented service oriented distributed routing protocol. So from here, my friend here, Anirban, he'll explain the system architecture as well as the working proposal.
The system architecture, as you can see on the screen, consists of access points which are indicated in blue triangles and the mobile nodes which are indicated by black circles. So as you can see, it is a mixture of access points which basically converts the wireless signals into wired signals, and which are not movable, that is infrastructure, and the mobile nodes which can move from any point to other point, and they are wireless. So we are considering our source node as a mobile node in this case, and here, as the name suggests, hybrid wireless networks, you can see how the both of the access points and the mobile nodes are working together. So this is the basic data flow diagram where the user logs in, then the check is done where the source, router and destination IP addresses are given, then the data, the packets are forwarded according to the IP address through the intermediate routers. So as my friend suggested, our project is divided into 5 different modules. The first is the network and service models, the neighbor selection algorithm, the packet scheduling algorithm, the packet resizing algorithm, and the redundancy elimination algorithm. The network and service module. We consider a hybrid wireless network with an arbitrary number of base stations spreading over the network. Mobile nodes are moving around in network which uses IEEE standard CSMA protocol. Since a hybrid wireless networks are equipped with multi-interfaces that transmit packets through multi-channels, generate much less interference than a hybrid network which are equipped with a single Wi-Fi interface. The neighbor selection algorithm module does nothing but solves the problem of how to select the intermediate nodes that can guarantee the QoS or quality of service of the packet transmission, and from the available number of nodes, how to select the node which will give the maximum efficiency and optimization in forwarding the packets. The packet scheduling algorithm reduces the stream transmission time. A distributed packet scheduling algorithm is proposed for the packet routing. This algorithm assigns earlier generated packets for forwarders with higher queuing delays and scheduling facilities, while assigns more recently generated packets to forwarders with lower queuing delays and scheduling feasibility, so that the transmission delay of the entire packet stream can be reduced. The packet resizing algorithm. We use a mobility-based packet resizing algorithm for QoD. The basic idea is that the larger packets are assigned to a lower mobility intermediate nodes, and the smaller packets are assigned to a higher mobility intermediate nodes, which increases the QoS guaranteed packet transmission. And finally, the redundancy elimination algorithm. We can increase the scheduling feasibility of the intermediate nodes and thus sequentially increase of the QoS of the packet transmission. Due to the broadcasting feature of the wireless networks in a hybrid network, the access points and the mobile nodes can overhead the cache packets. We use an end-to-end traffic redundancy algorithm, or the TRE algorithm, to eliminate the redundancy data to improve the quality of service of the packet transmission in QoD. So here you can see some of the screenshots. This screenshot is for the client, which has an IP field, a port field, and the file selection field. This is the screenshot of the server, which has only the port number for listening. This is a localization simulator screenshot, and these are some of the screenshot where is the file is sent, the incoming connection is accepted, the listening port is listened in the server, and the new file is finally received. So in this simulation you can see how the neighbor selection algorithm acts on the basis of the possible available nodes and which nodes are to be selected. So this is a result which has estimated node and actual node and the time required to forward the packet. Conclusion. Hybrid wireless networks that integrate managed and infrastructure wireless networks have proven to be a better network structure for the next generation of networking. Taking advantage of the unique feature of hybrid networks and the anycast transmission and short transmission hops, QoD transforms the packet routing problem to a packet scheduling problem. In QoD, a source node directly transmits packets to an access point if the direct transmission can guarantee the quality of service of the traffic. Otherwise, the source node schedules the packet to a number of qualified neighboring nodes. Thank you. Now, my friends, will go to the simulation. Here you can see the client part, and here you can see the server part. So first, being on the same machine, we assign the loopback address, which is 127.0.0.1, and we will give the port number as 5000, and we'll select some random files which are present on my desktop. Let's say the AA text file which is present on the desktop itself. So file is selected. Now on the server side, we'll just give the port number as 5000 as we have initially given in the client side, and we'll start listening. So the port on 5000 is listening as the server. Now we'll just have to send the file. So you can see the file is sent, okay, and the incoming connection is accepted, okay, and you can see the new file as.txt is received. Now after clicking OK, you'll see a new folder will open which will have the file as. So in this way we can conclude that our project demo is successfully working. Now coming to the localization simulator, we'll deploy the wireless sensor networks, we'll estimate position, we'll use a localization algorithm, and we'll give locators antenna type as directed, and we'll start the simulation. Here you can see the possible nodes have been marked in blue. This indicates that the possible nodes which the router can have for sending files in between them. Thank you.